I just recorded it and it got deleted and we're recording it again. So, today we're talking about modeling with linear functions. Specifically, we use the standard form often when we're thinking about models. And this little mini chapter is really exciting because often students are like, when am I ever going to use this, right? So, today is the day we start talking about real life applications. All right, so the standard form of a linear equation is written ax plus by equals c, where a, b, and c are all real numbers and a is positive. All right, so to graph from this standard form, we x and y intercepts. And so we're going to do a little refresher about what those guys are. So I have a corny way that I always say this. It's kind of repetitive, which is the whole point. So the x-intercept is the x-coordinate where the graph crosses the x-axis. And the y-intercept is the y-coordinate of the point where the graph crosses the y-axis. All right, so before I start talking to you about what all this process is going to look like for graphing, I'm going to make a little quadrant here. Whoa, those lines are crooked. I don't know about you guys, but I write like with my page slanted, or I guess in this case my iPad, and so sometimes I think I'm drawing a straight line, and then I turn my iPad so that it's like straight on, and I'm like, whoo, what is that? All right, anywho, on the x-axis down here, right, y is equal to 0 because we didn't move up or down at all. And on the y-axis up here, the opposite is true. X is 0 because we didn't move left or right at all. So we're going to use that fact to be able to find the x, y intercepts and then graph. So first things first is we're going to set y equal to 0 and solve for x, and that'll give us the x coordinate. And then we'll set x equal to 0 and solve for y, and that's how we'll find the y-intercept. And then we'll just connect the dots. So this won't be the most precise line, right? Because instead of drawing 3, 4, 5 different points, we'll just have the 2. But if you use a straight edge, or in my case the iPad that straightens the line for me, it can be pretty good. Alrighty, so let's go ahead and graph some equations. So I like to draw myself a little squiggly here so that I can find one intercept on one side, one intercept on the other. So first we're going to find the x-intercept. So we'll have 2x plus 0 equals negative 2. Whoa, what happened to my 0 there? That was kind of funny. Alrighty. So that goes away. So I've got 2x is equal to negative 2. Then we'll divide both sides by 2. X is negative 1. So I'll just go ahead and plot the intercept right there. Now we do the opposite for y. So I'll plug in 0 for x. So that goes away. That becomes 0. Got y is equal to negative 2. Perfect. Plot that point and connect. All right, looks pretty good. All right, first one done. Let's look at the next one. And I promise after this we'll get into the applications. All right, so we're going to have x minus 3 times 0 equals 9. So that means x is equal to 9. All right, and the next one we're going to have is the x equals 0. So we'll have 0 minus 3y equals 9, which is just minus 3y equals 9 divided by minus 3. You get y equals negative 3. Like so. And then connect the dots. You know what? Oh, that was kind of ugly. Let's try that again. Go through there, go through there. Yeah, good enough. All right, so now we can actually talk about some real world examples. So, linear functions in the standard form are often used to model situations. So, like a real life scenario. Okay? Graphing the equation and then interpreting the intercepts and context can be helpful to determine possible solutions. All right, so let's see this in action here. A pizza shop sells small pizzas for $8 and large pizzas for $12. You have $96 to spend. I would love to have $96 to spend on pizza, just saying. Let X be the number of small pizzas. All right, so I'm going to kind of label here. Small pizzas down here. Number of small pizzas. And Y is the number of large pizzas. This can be modeled by the equation 8x plus 12y equals 96. All right, so let's graph the equation below, and then I'll tell you how we can go about interpreting the intercepts. All right, so if I've got 8x plus 12 times 0 equals 96. We'll have 8x is equal to 96. Divide everything by 8, and that means x is 12. So what this means is y was 0, remember? So we could buy 0 large pizzas and 12 small pizzas. For $96, right? Spending our whole budget. So then this point goes right here. All right, let's find the y-intercept. So this time I'm putting in 0 for x. You may have kind of noticed how this is going to play out already with this particular equation. If I divide both sides by 96, I'm going to get 8. Okay, so we could buy 0 small pizzas and large pizzas for $96. So that point would be right here. All right, and then I'll go ahead and connect those dots. Like so. All right, so anywhere where a graph kind of touches a whole number point, that would be a possible solution. So like here, this one is 3, 6. This one is 6, 4, right, and so on. So with the X telling us the number of small pizzas, the Y telling us the large pizzas, and it being on the line where our 8x plus 12y was equal to 96, that means we're spending exactly our 96 budget. If you wanted to think about an inequality, right, if we shaded underneath our budget and included it with a solid line, then any whole number points, right, because they don't let you buy partial pizzas, would be part of that solution set as well, which is pretty cool. All right, so we talked about pizzas, one of my favorite things in the world. Now we're going to talk about school supply shopping, one of my other favorite things in the world. All right, Mr. Liam is shopping for school supplies. We're going to highlight some stuff in here because there's a lot of information to unpack. He has $30 to spend. That's his budget. Notebooks are $2 each. And his favorite markers are $1.50 each. We're going to let X be the number of notebooks that he purchased. All right, so I'm going to go ahead and label that really quick on my graph. So I know that the number of, oops, forgot to use my color coding here. This is his number of notebooks down here, the X's. All right, and then you keep going, we're going to let Y be the number of markers that he purchases. So then, okay. It's like, oh, my preset color is just disappeared. Number of notebooks. Number of markers. Okay. Okay. The graph below is showing us the function, right? So I've already graphed it. But we can go ahead and write this equation. So what's happening here is we first need to think about our notebooks. So if they're $2 per notebook, that means we could have 2 times however many notebooks we got, or 2x, plus whatever we spend on markers, which is 1.5 times the number of markers, 1.5y, and that's going to be equal to our budget, $30. Right, so here he's aiming to spend exactly $30. But like I said with the previous one, we could just as easily use an inequality to model this and think about spending less than or equal to $30. All right, so points on this line here are those intercepts, right? So, and any whole number, because again, like I said, they don't really let you purchase parts of a notebook or parts of a marker at the store. So I just wanted to talk about 3 possible solutions. If you notice, I found way more than 3 points on here. But let's see. 316, that's an option. 612, that's an option. And 9, 8, that's an option. All right, so let's think about what's going on here. So 316 means that I could get 3 notebooks, 16 markers. I could get 6 notebooks and 12 markers. Or I could get 9 notebooks and 8 markers. Of course, those aren't the only solutions. Those are just 3 of them. All right, there you have it for the second time. Student form of linear functions, model in some situations. Love you. Bye.